Welcome to our 2D Physics Education tool, Senior Capstone Project Video Overview. This here is our scene selector, and it selects scenes. Clicking on these buttons will open up the scenes, and that's all that this section does. Let's take a look at the gravity simulation. So we click the gravity button, and it holds it up. So along the top here we have our GUI. So spawn button spawns ball. This is our gravity slider. You can see it changes the value of the gravity. We have a readout of the velocity of the ball, and then once the ball is done rolling, it'll update this with how long it took. And here's an info button with an informative text box, and you can also click, but that's no fun. So first of all, we'll spawn a ball. We'll slide in, roll down, and it'll reach the end and say how long. So we can see if we change the gravity up higher, and well, this one took 5 seconds, this one takes 3.5, and you can scroll through this text box. Or if you change the gravity to 0, there's no more velocity. So, or if it's 0, it won't even start falling until you make it be something, and then it'll move the constant velocity afterwards. So this scene gives an intuitive understanding. If there's 0 gravity, nothing happens. If there's more gravity, stuff happens. If there's faster gravity, it rolls even faster, and you can see the relationship between how strong the gravity is and how long it takes. If we do 476, it'll take a lot longer than if it was at 2000. So this is the gravity scene.
Alright, so now we're going to look at the Plinko simulation that we've created here, so we'll open that up in our scene selector. So this is our Plinko game. We have static letters and balls on the screen here, so it spells out Plinko and then Oakland. So the goal of this would be to spawn a coin on the top of the screen, and then it'll fall through the static objects that we have placed on the screen, and then they will fall and collect the letters of Oakland. So the goal would be to do that in as least amount of coins as possible. So what this says is click to spawn the coin, and then click R on the keyboard to remove them. So we'll just start over here. We'll spawn a few coins and see if we can gather the letters of Oakland. And let's see what happens. So the balls fall down with the gravity that we have implemented, and they collide with each other. So we have the object collision all incorporated in with this as well, and then the gravity. And we'll try to get the end real quick. And the coins just react with each other, fall down, and then they do their own thing. So, and then when the user's done, they can click R, which then removes and then can be reset to play the game again. So we just wanted to implement this to have a fun little game to demonstrate the gravity and then the object collision between the coins. And that is it for the Plinko simulation. Alright, next we're going to open the air resistance simulation. So we'll click on that and open that. So here is our slider to change the amount of air resistance that is being displayed on the football. So we'll put it back to where it was. So the user can click on the info button to figure out how to use the application, and then we can click R to just reset there. And then it says move the slider to either increase or decrease air resistance, and in the info, as you hold down on the screen, the bar on the left fills up. So that's the amount of power. So if we're above like the 30-yard line here and we shoot, let go and shoot, it went to about the 40, and we're near the top here, and we'll change the amount of air resistance. And we have a dead zone up here so that the football will not get thrown when the user's clicking up on the top of the screen. And we do it again. As you can see, the ball does not go as far due to the amount of air resistance that is being applied to it. And we shoot it again, and we can see with 0 air resistance if we aim higher. But since we're in a dead zone, it won't work. If we're down here, it'll go as far as you can get it, and then the max amount of air resistance. So we wanted the users to be able to play with this and see how the amount of air resistance affects the object. And then we have the quit button as well, and then that'll just bring you back to the scene selector. Alright, so now we're going to get into our spring simulation, so we'll click on that and open it up. Alright, so here's our preset up simulation that we have here. We have our GUI up at the top, and then at the side here to spawn different shapes. So a lot of these different features are displayed in the sandbox simulation, and we'll go into more in depth on those later. So but we have the mass and other things up here that we'll be using, so like changing the radius slider and all that. So we'll go into the info button that we've coded up here, and you can scroll through that to view how the simulation works, and then you can dismiss the message, and then I'll go into more in detail of what was in there. So the goal of the simulation is to spawn and then destroy objects. So we will click on the circle and we'll spawn it with the default radius size here, and the mass of, we'll do 20 for the sake of this. And then you spawn that in, and then we'll do another one that's just a bit bigger. And then let's do another one with a mass of 30, and we'll spawn that one here. And then we'll do another one with this different size, that is mass of 35. And we'll spawn that one here. So now the user can create a spring by clicking on the spring here, and we have the stiffness and dampening options. So we'll do something that's more stiff and then less damp for the first one. And then we'll do something maybe that's even more stiff and a little more damp for the second one. And then we'll do one that's super stiff and more damp here for the middle one. And then we'll do one that's not stiff at all but super damp on the very last one. So now the user can turn on destroy mode and pick off a different shape that's not the spring, and then they can hit on the square underneath to destroy the object, and you can see the spring react depending on the options. So with the first one going, you can click the pause button, and then it'll pause everything on the screen, and then the user can click the pause button again to unpause, so you can see how each one reacts. And then we'll destroy the second one here, and we can watch it move. And then depending on the settings that you select and everything like that, the spring may just drop down or not bounce at all, and you can watch that happen in real time as the different shapes fall. And we'll do the last one here, just clicking on the screen, and then see, since that one is not damp or super damp, it'll just drop down to the ground. So then the user can click R to reset on the keyboard, and say if we'll turn back on spawn mode, and then say if the user dropped a shape off like that, in the info button it shows you can right click on it to destroy that shape. And we can also change the mass up here, which I've already gone through, but we'll bring it back to 20, and then we'll change the gravity on the simulation. We'll bring it down to, let's just say 400, and then we can do one spring simulation with that. And then you can click on the circle again, make sure spawn mode's on, change the radius, and then we will create a spring on that one that is stiff and not as damp. And then as you can see, the gravity, since it's not as affecting as much, it'll pull the object up, and then that's the spring, and you don't have to destroy the object. And you can click on the quit button, and then that'll bring you back to the scene selector.
Now it's time to look at our friction scene. So here it looks very similar to the gravity scene when we start, except there's a cube, and also there's two sliders. So this slider here changes the friction. So more friction, it'll slow down, eventually stop moving. If we lessen it back up, it'll start moving again. And this impacts the slope here. So we can see with this amount of friction, here with this slope, it will barely move. It won't move at all. If we increase it, obviously it still stop rolling, and we decrease it, now it actually start rolling. So you can play around with this to try to get it stopped with any certain angle and see how much friction that would take, and see, oh, if it's a bigger angle, it'll take more friction to stop it, compared to if it's a shallower angle, it will take less friction for it to stop moving. And also, once it gets to the very end, it'll put up a status message, just like the gravity simulation, of how long it took to get to the end. So if we were to spawn in another cube, we could see how fast could you possibly make it go. Well, obviously, trying to do it with full friction is not going to move very fast, but if you decrease that to 0, you can get a much better time. "3 seconds. But if we were to change the slope up and still have no friction, it would go a lot slower, and we could slow it down to a stop, but then with the more steep slope it would still be able to side, where with a less steep one it wouldn't. So that is our friction scene, and here is our info box associated with it. This is just if the user wanted more help, and that is all for our friction scene.
Alright, so now we're going to get into our Angry Bird simulation, so we'll click on that here. Alright, so now this opens up same GUI that is implemented in with other scenes that we've created, but we're basically going to use the mass in this one, but you can mess around with the gravity and other things like that as well. So we have our bird here. This is similar to our air resistance simulator, so when you shoot, the bird will fly, but you cannot change the amount of air resistance getting applied to the bird here. So you click R to reset just like before, but we will click on the info button, and the user can move that around, read through it on how to use the simulation, click dismiss, reset again. Alright, so now with the Angry Bird simulation we can spawn and destroy different squares that we can spawn in, or rectangles depending on how you change the width and height. So we can change the size of these, and so if we make a square on top of that, spawn that in, and then if you left click you can shoot the bird at it. So with a mass of 10 you can see that the bird hits it pretty well and it moves, and if you click R to reset it'll only get rid of the birds, which is great. So then you can go back to the, you can turn on move mode and then right click and you can move that object back, and then let's spawn another one on top with a mass of, let's just go really absurd here and go like 50, and then we can spawn that shape on top of there, and you can see since it's heavy it'll move, and then if you try to shoot it, it doesn't move as much as the mass of 10 due to the fact that it weighs much more. So we can turn back on move mode, we can move these back, and then if we wanted to destroy the heavy one you can right click if move mode's off, and then it'll destroy that object. So then we can click on the pig button and make sure to spawn mode's on and move mode's off. You can spawn the pig on top, and then he has a mass of 50, which if you forget to change that you can just click R, and then you can type in the mass of 10, which is like default for our simulation. So we can spawn him on there and he won't move as much, and then we can left click to get the bird back, and then we can shoot the bird at the object that was created, and you can see that all the objects mess around with each other and collide very nicely. You can click R, and then you can destroy the objects that were spawned and reset the simulation. So if we wanted to make something that was further away, we can turn back on spawn mode, and then we'll just create a set of things here to protect the pig, and then we'll put a roof on it. Oh, wrong way, sorry. Reposition that, put a roof on it, and then we can destroy mode that, and then spawn the pig, and we'll put one on top too, and here, and then we can left click to get the bird back, and then we can shoot at what was created, and as you can see everything reacts very nicely with each other, and it looks very good when everything is destroyed. So the user clicks R to reset again, like I've mentioned, and then if they wanted to move these shapes around they could, and then if they want to delete them they could do that as well to reset the scene. And then we can go destroy mode and then spawn mode, and then you can also mess around with the amount of gravity. So say we want 0 gravity in our simulation, shoot the bird and there's no gravity affecting it, so it'll just go on forever. And if we change that to like 50 or something, you can see that they start to fall, but the gravity's a lot less. And that is our Angry Bird simulation, and then the user click quit to go back to the main screen.
Hi, I'm Julia, and I'm going to be demonstrating our sandbox feature. Sandbox can be accessed from the scene selector by this lower button right here. Click on it and it will open up the scene. We have our playground in the middle where you can spawn in various different shapes, and we have the variables up here as well as a control panel on the side. You can click on the circle and then left click in the middle space to spawn in a shape. and it simulates the actions of a ball. We can, in real time, change the amount of gravity that occurs. And we can see that the less gravity acting on the balls, the slower it reacts. Note that when I have to enter the values into these top variables up here, I have to hit the enter key in order to finalize my choice. Just clicking off of the text line input will not change any variables. Similarly, if I wanted to, well, first let's change the gravity back to 900. If I want the elasticity, if I want these balls to not be so bouncy, I can just hit 0 on the elasticity and then it doesn't bounce. It just drops. And then for something fun, we have a little color picker where I can change the colors of the shapes. Just something fun. And if you notice up here, we have the radius slider where we can change the size of the ball. And if you cycle through the various different options over here, you notice that the sliders change from width to height to radius. For this is a attachment, so it would not have one of these sliders affected. But we can see, let's put this back to the default. This will be a standard square, but if we change the width, it'll be more of a rectangle. I can change this, build whatever we want. Now these are all fun and good, just bouncing along, but what if I wanted to make something static? Well, then I would make sure that the static shapes mode is on by switching between the kinematic shapes to the static shapes. Pick my shape, change my variables up here, and then I will have these static shapes. And I can switch back to the kinematic and have them interact with the static still. I'm going to clean up a little bit here by switching to destroy mode, which I can click on the spawn mode button to switch to destroy, and it starts to destroy all these things when I left click them. Alternatively, if you're in spawn mode and want to quickly destroy something, you can right click and it will destroy as well. Destroy mode works on the static shapes as well. Let's put in some more shapes. This time, let's get some triangles in. And let's get some elasticity on these triangles. So, seeing all this is well and good, but we need to see some numbers in order to get a better feel on how physics works. So we have a query mode, and we can click on an object to get the query. It's kind of hard to see because of the red, but there is a small indicator saying that this is the shape that we queried. And then we can, let's move this for a second. And if we notice, as it moves, we can see the different velocity changing back and forth. We can also affect it, and so that the x value of the velocity changes as well. Other things in the query, return in the query mode are mass, elasticity, and friction. The same things up here. So you're going to identify which shape is which. Let's move this off. Last thing to demonstrate is the attach feature. So we have here this funky little shape here. It's actually supposed to demonstrate, represent an attachment, a joint, so to say. Let's first get another ball out and delete these triangles. So if I do this, then there's an attachment in between these two shapes. And then once I move, let's see here. Spawn mode is on, move mode. Oh, I know why. It's because I still have the attachment shape selected. I have to click off on onto something else, like say the circle. But yeah, once I have that move mode selected, I can freely play around. And what's fun is that you can attach multiple shapes to one another. So say I have the attach another shape, I select a circle to deselect the attachment, move mode is on, so I'm going to select this one. And I got this perpetual motion of a sort of pendulum of sorts. Let's put this down. We have a little bit of info demonstrating some keyboard shortcuts. There is P to pause and R to reset the scene. You can also rotate objects by using the scroll wheel. So let's spawn in a square, move mode, and then I'm scrolling up and down to rotate the shape. This is handy in case you want to make a pretty picture or something. But I believe that is the extent of the sandbox. This has been a demo of the 2D Physics Educational Tool, programmed and designed by Brendan Fraser, Martin Hughes, Reese Sikorsky, Yi Duong, and Julia Wong. Thank you very much, and we hope you have a good rest of your day.